So they're the one-liners really of what's happening in the regulations. Going through them now section by section, and not skip the import. I've skipped the parts 1 and part 2 ones, of course. Straight into part 4 where there are some concerns now. So a more clarification really on, do we need to do protective bonding where we have insulated inserts into pipework or insulated collars into other pipework. We only need to actually protective bond extraneous conductive parts. So that insulating section is likely in itself to make it not an extraneous conductive part. If you remember, an extraneous conductive part is something that's conductive, i.e. usually metal, and actually comes out of the ground. So if there's an insulating section after it comes out the ground, or as it comes out the ground, then the whole metal pipework might mean that it's not an extraneous conductive part, and therefore will not require protective equipotential bonding. No real difference in the regulations before, just some clarification of the words. Where there is the first real difference, I guess, in the 18th edition is to do with disconnection times. Now, table 4.1.1 gives us the table for disconnection times required for circuits. Now, in the 17th edition, this table would say this table is relevant to final circuits up to 32 amps. Which was okay, but then they realised reasonably quickly that final circuits up to 32 amps could well exclude things like the cooker circuit you can see there, or the underfloor busbar systems, which are commonly on circuits greater than 32 amps. So that actually meant that you could plug something into that socket, be holding this portable piece of equipment at the time when a fault occurs, so you could be holding a fault for up to 5 seconds, which is obviously not desirable. So correcting that means that all circuits now with socket outlets generally will not be more than 63 amps. So any circuit up to 63 amps, this table applies. Any circuit with 63 amps up to socket outlets, this table applies. Or any final equipment that's only fixed current using equipment up to 32 amps, this table applies. So it's had the effect really of dragging those kind of applications into this 0.4 seconds disconnection time for TN, or 0.2 obviously for TT systems. The disconnection times for distribution circuits, or if this table doesn't apply of course, are the same, i.e. 5 seconds or 1 second for TT systems. RCD protection socket outlets has been expanded somewhat. Again, the regulations would have said, or the 17th edition regulations say, socket outlets up to 20 amps had to be RCD protected unless you did a couple of things to exclude that. So that was generally then the 13 amp socket outlet fell into that category, being less than 20 amps. Now what the regulations say, socket outlets up to 32 amps. So if anyone does any commercial industrial work with the the IC socket there, that brings that into this RCD requirement. So up to 32 amps then, if it's a 230 volt socket, will require RCD protection. Now, we had two ways before of not including RCD protection, because sometimes, of course, if it's critical equipment, IT server equipment, it's not desirable maybe to have RCD protection on those socket outlets. And what we was allowed to do at the 17th edition is specifically label the socket outlet for an item of equipment for a reason why we do not want RCD protection on this socket outlet. So we could have labelled either of those socket outlets IT server equipment only, IT equipment only. So you could have even labelled it, funny enough, fridge only for a domestic use, which actually could be easily abused. So the labelling requirement or label allowance has actually been removed. You cannot label a socket nowadays to not exclude, to not have RCD protection. So how do we now have a socket without RCD protection then? There is still a way, but that way must be for a documented risk assessment being performed. It's not permitted in a dwelling. So what that means is that every socket out in a dwelling, regardless of its use, regardless of where it is, will require RCD protection. Most are, of course, nowadays anyway, so that's not really a problem. Now, in commercial applications then, the IT server room, you will have to carry out risk assessment to make it clear that that socket does not require RCD protection. And that risk assessment will involve things like what equipment is connected, who's got access to the area, and all sorts of information that says why you do not need or want or have to have RCD protection on this socket outlet. This risk assessment is important, of course, and it has such importance it will need to be attached to the electrical installation certificate. There is a small square box on the electrical installation certificate for you to tick to say, yes, you have attached your risk assessment. Additional protection or with RCDs for circuits in luminaires. So this is a new regulation. So within domestic premises, RCD protection is required now on all circuits with luminaires. 17th edition rules would only require RCD protection on lighting circuits because the cable is usually within the wall. So on this picture here, you can see maybe the cable wired surface. So under the 17th edition rules, there's no real requirement to actually RCD protect this lighting circuit. So what would happen now then? It's got more implications here on, or additions or alterations. What would happen if we want to extend maybe the lighting circuit here and add another luminaire? Well, the existing circuit, if it isn't RCD protected, is fine, but our new work will have to comply after January to the 18th edition and will require RCD protection. So probably the easiest way of carrying this out would be to put back at the consumer or distribution board an RCD or RCB at that point. So you're not obliged to RCD protect the existing circuitry or existing cabling, but it's probably the easiest way of applying RCD protection to the new work which you are installing.